Hello to everyone. In this video lesson, I would like to show how new joint inversion criteria works. So we added recently several and we tested it, but not so many projects was used for testings. I just show you a new set of criteria in this submenu. And there is two of them, first and second. It was in previous updates and also added four. So cross gradient is already classic and everyone uses it, and it's trying to reinforce different models borders. So it's trying to find place marked by borders, and if there is no borders from one method, there is no problem. Common correlation criteria is a good one if you have a correlation between some targets in two different methods, or anti-correlation, so it's no problem. So it's good for such method as such combination of methods as gravity and magnetic or resistivity and IP. Next group of three criteria is very close to cross gradient, but use additional correlation criteria. So it's looking for correlation between borders, so between contrasting two models. And this one is double cross gradient. I'm not sure it's a good one, so if it will not helpful, I will remove it. It's the same like a cross gradient, but use double gradient. So I suppose it may work in case, for example, of combination of ERT and refraction seismic, because refraction seismic has usually natural gradient of pressures. And this is a problem for cross gradient inversion because resistivity can have or have not the same gradient. So, and last one I would like to present today's global local correlation. Idea of this criterion is to make contours of both methods match maximally good. So if we see anomaly on one model, we expect to see the same anomaly contours on the another method. Of course, from geological point of view, it's maybe wrong because it's, for example, nothing in common in both sections. But this is just idea. If you have such correlation in petrophysics, this criteria will be best for you. And when I said correlation, I mean correlation and anti-correlation. So here is a data set, resistivity, ERT, and I have in this project seismic data, this one. So I would like to show a comparison of classic cross-gradient inversion and last criterion. So I would like to check parameters, first cross gradient, and choose pushing factor. For cross gradient, we need big one because this criteria is band limited, so it's not have a big effect on the inversion. So let me check what result will be this cross gradient inversion for this couple of data sets. So here is will be some graphics coming. during inversion shows optimization of RMS errors and cross-gradient target function. So black one is target function cross-gradient, and red and blue is for resistivity and SRT. So this is cross-gradient inversion, and it should mark better these contrast boundaries. It's maybe different polarity, of course, because gradient shouldn't be the same. So not from minimum to maximum, no matter. It's maybe one method from minimum to maximum, another method from maximum to. And I suppose this is enough because we have a good changing of cross gradient and good RMS for both methods. Let's check. So here is seismic data. It's about 1% of RMS, and RT data the same level. And you can see both models. I'll plot it as a contour. And yes, we can find some elements in this section which has a correlation, so some boundaries, but not that much. So I don't say it's wrong. I just say that sometimes you need better matching between contours of anomalies. So let's me build it this way, and this, I suppose this boundary is the same like I show by mouse. And I'm not sure, but maybe this is correct. Okay. This is what I got with classic cross gradient. And now I'll switch to the last criteria, global local correlation. I name it this way, but maybe I'll rename it in the future. Just very fast naming, very quick. Okay, for this method, because it's use full operation like Jacobian matrix, it has the same dimension, so it's very big, and joint inversion will be slow because they operate additional very big matrix, and calculation of extra parameters takes a long time, but not that much for so small sample. Another stuff, because this matrix, this operator is very massive, they need to make our pushing factor very small because it's push anyway because of very big size operator. Oh, they always need to choose correctly, properly this parameter. And another stuff, I recommend this kind of inversion without smoothness, additional minimization, and I mean flattens target function, and line search. Line search is very required. It's not necessary because we choose practically equivalent operator, and they can point solution in different directions. So it's neat very special solvers like SVD, but we do not use it because they're very slow. So better to use line search in this way. And small values of pushing factor should be less than 1. But you can check on your data sets which one is better. Okay, now I'll try to run joint inversion and can see how slow it is in comparison with cross gradient, but it's not so slow on the first iteration because there is a small operator on the first iteration and it's became full since second iteration. So now it should be much slower. Also, we will never face the same RMS, same small RMS with such inversion. So it should be not less than 1, but something like 1.5, maybe 2%. Because really this Jacobian and this operating can lead to different solutions. We're just trying to find contours matching. So this was second iteration. And as you see, it's much slower. It was in cross gradient. So in this problem in joint inversion, we solved several tasks. This is forward and Jacobian problem for seismic forward and Jacobian problem for RT. And also we have this joint operation which costs nothing for cross gradient and for some another criteria, but for this it will cost. And every step of optimization need to recalculate it. So yes, it's maybe slow. So relief of this decays not the same, and level of RMS, you see black line, so pretty of joint inversion is much bigger. It's much bigger because it has another very massive operator. So it's take big part of energy of full inverse problem. But anyway, you can see it's go down. And our RMSs also go down step by step. So I think 10 iteration are usually enough for joint inversion. And sometimes it's even less if you see that there's nothing changed. But it's always can happen changing after some iteration because it's joint inversion and it's have a different inertial momenta in comparison with standalone. If standalone go down and goes to straight line on some level, you can stop. But everything can change to this joint inversion. But let's wait till our inversion RMS faced smaller value and we can stop. Hope you keep in mind picture we resolved for cross gradient because I didn't put it in a buffer for comparison, so we can compare results only using our memory, or you can use it. You can use YouTube video to get back, check how it looks like. Model is look the same, but actually it's not the same. And all these small details, which will, when it's finished, we will compare, will moved to another place, and anomalies will be much better than it was. Okay, now just relax and wait till it finished. I'm pretty happy with this smooth process of decaying. Giant inversion target. There is some small oscillation between methods. Okay, now it's finished. We can check for our seismic model. And this one. Where is seismic? Yes, it looks pretty same. You can see very good correlation for this element, anti-correlation. This element do not be surprised of upper part because I took it off from joint operation because first meters of section used to very different, and we don't need to have a correlation here. So yes, all anomalies here correlate pretty good and contours match pretty well. It's not, maybe not correct from geological point of view, and especially for seismic and ERT. But if we need this, we can use this criteria and it will show better result cross gradient, for example. So I think this is all about, and you can get back to in this video to part this cross gradient inversion to compare result with this criterion. So thank you very much for your attention and hope it will help you with your interpretation.